All right, we are on page 4 of the study guide in part 6. In this top part, you are asked to calculate the indicated measures, and you're given the choice. It says leave your answers in terms of pi or rounded to the nearest hundredth. So I'll go through both solutions with you. So in number 1, you are asked to find the area of sector CDE. So you're asked to find the shaded area. You're given the central angle, the arc angle, and you're also given that the radius is 6. So if we think about, this is a lot like our mile marker question, and we know that the central angle over 360, that comparison, that ratio is like a part to whole comparison, and that's going to be equal to the sector area over the area of the entire circle. So when we go to fill out this proportion, I know my central angle is 70 degrees. I know there's 360 degrees in the circle. I don't know my sector area. But when I find the area of the circle, I know I've got to do pi times the radius squared. So if my radius is 6, 6 squared is 36. So my area is 36 pi. Now if you're going to leave your answer in terms of pi, then in your proportion you would just write 36 pi. And when we find the area, we know it would also be in terms of pi. So I'm going to say x times pi. So I really just have to find that multiplier of pi that corresponds to 36. All right, so we can cross multiply. So I get 360x times pi is equal to 70 times 36 pi. And my pi's cancel out. You can also cross multiply really without the pi because they're going to cancel out. Let's see, so now I have 360x is equal to 2,520, that's 70 times 36, and then divide both sides by 360. So I get that x equals 7. So if I leave my answer in terms of pi, that's going to be 7 pi is the sector area. Now, that's how we've been doing these problems on the mile marker, so it seems like that would be like the easy way to do it. However, if instead you multiplied by pi when you found the area, so if you took this 36 pi and actually multiplied 36 times 3.1415926, you would get the area is approximately 113.097. So that's now an approximate answer. And then you would set up the same proportion, but you would do 70 over 360 is your unknown over 113.097. And if you do it this way, there's no pi in your proportion now because you've multiplied through by pi. So when you cross multiply, you'd multiply that number by 70. You'd get that equal to 360x. And then when you divide by 360, you would get that x is approximately 21.991. And this is going to be in centimeters squared. So let's put our units in there. And this is still centimeters squared. So either 7 pi or 21.991. And if you aren't sure if you did that correctly, if you check in your calculator, if you do 7 times pi, you get that same number. Okay. Moving on to the next question is about arc length. We're going to use the same proportion, but now we're going to use the part where we're comparing arc length to the circumference. And we know we can find circumference with either pi times diameter or 2 times pi times the radius. All right, so if I look at the circle, my radius is 18 inches. So if I double that, my diameter is, 36 inches? So my circumference, if I leave that in terms of pi, is 36 pi inches. All right, the arc that I'm trying to find, and I think this is kind of confusing, it's this 110 degree arc, but those probably should have been connected. So you're really trying to find this arc. So we know our central angle is 110. So we're going to compare that to 360 degrees. And then we don't know our arc length. I'm going to do this one in terms of pi. So I'll write in my circumference, 36 pi. And then my arc length is my unknown. Again, you could just cancel pi in your proportion, but I'd say be careful of doing that because your arc length will have pi in it. And then if we can cross multiply, or if you look at this, if you simplify 110 over 360, if we just divide those by 10, we get 11 over 36. So if 11 over 36 is equal to x over 36, we know x must be 11. So your arc length should be 11 pi. And that's going to be in inches. All right, now again, if you did that and you multiplied out to the nearest hundredth, instead of using 36 pi, you would multiply 36 by pi and use, that's funny, it was 36 pi both times. That was not on purpose. You would use 113.097, and you would cross multiply, and so you would do 110 times 113.097, and then when you divide that 360 off from both sides, you would end up getting x equals 34.558 inches when you round. So that's your arc length rounded. It doesn't matter to me which way you do it. I think this way is easier since we've been practicing for the mile marker, leaving our answers in terms of pi. All right, number 7, or 37. Ooh, this is a good question, and maybe a tough one because we haven't practiced one like this. But the area of the sector is 30.54 centimeters squared. So that is not in terms of pi because there's no pi next to it. So that means that's already been multiplied by pi. You're asked to find the radius of the circle. This is a really good challenge question. So in order to do this, we need the area of the entire circle. So we can use our proportion 140 over 360 is equal to the sector area, which we're told is 30.54, over the circle area, which we don't know. So we can cross multiply. We're going to do 360 times 30.54, and we'll set that equal to 140 times the area of the circle. So 360 times 30.54. Sorry, I'm doing this off screen in my calculator. When I do that, I get 10,994.4 is equal to 140 times the area. Divide both sides by 140. And we end up with 78.531 is the approximate area of that circle. Okay, that's not the answer to our question, but that's the approximate area. Now, this question is asking us to find the radius of the circle. You can do that from the area because you know that area is equal to pi times the radius squared. So we'll just plug this in for A. That's 78.531 equals pi r squared. So now, because this isn't in pi notation, when you divide both sides by pi, you actually have to divide that by pi. So in your calculator, and remember pi is about 3.14, but you should have a pi button in your calculator that you can actually do divided by pi, and you should get 24.997 approximately. Oops. So 24.997, and that's going to be your radius squared because we just divided off that pi. So then if you're trying to find the radius, you need to take the square root of that. And we get 4.9997, which I would round, I mean, this number is pretty close to 5. I would say that my radius is approximately equal to 5. So that would be our answer for number 37. 37, and we should say 5 centimeters. It's really not a complete answer unless you include your units, so 5 centimeters. All right, last question on the study guide. You are given the arc length, and you are asked to find the circumference. That should be easier than 37. So again, we're going to use our proportion, compare 120 degrees to 360 degrees. And I happen to know, and you could do this in your calculator, that that's the same as 1 over 3. 120 is a third of the circle. So really, you could probably reason through this without the proportion. If that's a third of your circle, 10 is a third of your circumference. So I already, in my head, know the circumference. But if we were going to set up the proportion, I could say this is going to be equal to my arc length, which I know, 10 inches, over my circumference measured in inches, which I do not know. And you can use the original 120 over 360, or if you simplified this to 1/3, you could just do that. So if you cross multiply, I'm going to get 1 times my circumference equals 3 times that arc length of 10 inches. So my circumference equals 30 inches. So over here for my circumference, I'm going to put 30 inches. All right, that's it.